Good afternoon, everyone. I would like to welcome all of you to the Basic Electronics Lab, ES 1002. So we are total 13 today, TAs. We will be helping all of you for this lab throughout the semester, and total 6 TAs are here in campus to help you or in order to demonstrate all these experiments to you. If you have any query in between, you can ask through chats, or also after the lab you can ask. And one more important thing is that along with this lab demonstration, you can also perform the lab by on your own in your own time through the simulation. We'll demonstrate that after this lab. So basically today is the introductory lab. In this introductory lab, you will be familiar with all the basic components. Those will be helpful for carrying out the several experiments, and all the basic measurement instruments. Those we will be using for this lab. So basically, we will have to perform total 9 experiments. So today is the first experiment 1. Experiment 1 is the title of the experiment 1 is Introduction and Familiarization to the Lab Equipments and Common Components. Okay, so before going to that, I would like to say that all of you may be familiar with all these components. Those you are right now, you can see, though you may be familiar with. So first, we will like to start with the basic division of the components. All of you are maybe familiar with that we will have two kind of equipments, that active components and passive components. Passive components are those cannot amplify the magnitude or amplitude of the signal, or that particular energy that you have applied across it, and such as resistor, capacitor, and inductor. And on the other hand, the transistor and op-amp, all these are under active device. Those can amplify the amplitude of the applied signal, or you can say those can amplify the energy that we have applied. So before coming to that, let's discuss about a little bit about that first component, resistor. So in resistor, so I think you are familiar with that. Resistors, we are having several kinds of resistor in our lab. So basically in right now, you can see that these resistors, these are that carbon resistors. Those are available in our lab. Though there are several type of resistor, metal film resistors are also there, ceramic resistors are also there, single inline network resistors are also there, and also variable resistors are also there. So right now, you are observing that these are the variable resistors, and these are the fixed resistors or carbon resistor. So as uh, you can observe that the color may not be clear to you. I'll show you later in through my screen sharing that these resistors, the uh, carbon resistors are having color codes. Through color codes, we can estimate the resistance of that particular resistor given to you. So it is very useful technique to understand, or it is very helpful in order to perform day-to-day experiments. Otherwise, you have to measure all the resistors once, then you can, that will be very time taking. So I think all of you are familiar with the color code. The color, there are several colors. So colors are having different numbers. Values are there. Colors, different color codes for that color. Different values are there. So first start with that black. Black one. Black is a 0, and then brown. Brown is 1, and red. Red is 2. Then orange 3, yellow 4, green 5, blue 6, violet 7, gray 8 and white 9. So basically the resistors are having 4 color, or you can say 4 color codes are there. First 2 digits, first 2 colors stands for the first 2 digits. Let's say, suppose we are having a resistor with a color code brown, black, then red. So what will be the color? And then so suppose yellow or white, some value. So first one is the brown, that will go to the first digit, that will contribute to the first digit. So brown is 1, and second one is black, so that will be 0, that will directly contribute to the second digit. And the third one will contribute to the multiplier of 10. So third one is red, so it will be 10 power 2, or multiplier of 10 in order 2. And then white one, the next one, fourth one is for the tolerance. As you can observe, means as you can have the experience of handling resistor, that maybe you can have a particular value from the resistor color code, that will be something different. And if you measure it in through multimeter, then you will have some difference value. And maybe that tolerance may change depending on the temperature, ambient temperature, or different circumstances that will affect the resistivity of that particular material. So that is why the tolerance 1. So if we do not consider the tolerance 1, then for this color code brown, black, and red, we'll have a resistor value of 10 into 10 power 2, or we can say 1000 ohm, or 1K resistor. So in general, in our lab, as you can see from here, I don't think the color code is visible to you. I can read out the color code for you. So in this case, the color code color is yellow, brown, red for first 3 1. Yellow, then I think you can do it on your own. Yellow color, first one is yellow, then next one is brown, means 1, then next one is red, 2. So I think you can, all of you can calculate it, that the resistance will be 4.1 kilo ohm. Sorry, 5.1. 1 second. Now yellow is 4. Okay, 4.1 kilo ohm. Yeah. So that resistor will be 4.1. So in this way, you can calculate or estimate the resistance value from the given color code for a resistor. And after that also you can measure it through the multimeter. What is multimeter? We will come to that. Okay, so resistance is one of the passive component. Then we'll come to another passive component, is the capacitor. So capacitor is also one of the passive component. As I think all of you are familiar with that, capacitance means, so we have to store store charges. Depending on the capacity, we can mark a value for that capacitance of that particular capacitor. So, and I think you are familiar with this picture, that parallel plate capacitor. So in general, that the capacitor is in practice, that electrolyte capacitors are in cylindrical form. So inside that cylinder, there is a spherical coil of dielectric material and metal. They are rounded and to form that cylindrical form. So from there, these are electrolyte capacitors. As you can see from here, these are the electrolyte capacitors. So there are different type of capacitors are here. So first of them, that as I told you, that these are electrolyte capacitor. How to distinguish electrolyte capacitor means it will have some polarity. means you will have two kind of capacitor basically in broad category, polar capacitor and non-polar or unipolar, you can say. Polar in the sense that it is having fixed polarity of positive electrode and negative electrode. So electrolyte capacitor are one of them which are having a fixed electrode that is contributed for positive electrode, and next one is for negative electrode. But also we'll have different kind of capacitor, that is depending on that dielectric material, the names are different. So one of them are tantalum capacitor, ceramic capacitor, polystyrene capacitor, film capacitor, electric double layer capacitor, polyester film capacitor, and mica capacitor, and also polypropylene capacitors. So the and also variable capacitors are also there. So all these are different type of capacitors. Those are available in market also, and also in our lab, as you can see, there are plenties of capacitor, different types of capacitors are there. So from here you can, as you can see, I don't think it is visible to you that number, particular number. Let's say this is also say electrolyte capacitor, but the capacitance value is written here. And if you observe that length of the two electrode, those are uneven, those are not even. So that greater one, the electrode with longer length, that is contributed to that positive electrode, and the small electrode with smaller length, that is negative electrode. And also negative sign is over here. So from there you can distinguish that which one is positive electrode and which one is negative electrode. So this is basically a electrolyte capacitor, and the capacitance value is directly written here. If you cannot see it, then I can read out for you. So it is 100 microfarad capacitor and 25 volt. So it is 100 microfarad and 25 volt capacitor it is. So this is one of the electrolyte capacitor, and this is ceramic capacitor. In case of ceramic capacitor, I think the numbers are given in form of, let's say, for this capacitance it is given 104. The number will be 104. So from the number you cannot say directly the capacitance value. So here also there is coding is there. So first two digit will contribute 104. So first two digit will contribute to the directly digit 1 and 0. Then second one will as similar to the color code of that resistor, it will be the multiplier. So 10 power 4 it will be in picofarad. In picofarad. So total capacitor will be 10 into 10 power 4 picofarad, or in other words you can say 10 power 5 picofarad, or you can say 0.1 microfarad. So if you have to experiment with the smaller value of capacitance, then you have to go with that. In general, that picofarad capacitor or ceramic capacitors, those are having with less value of capacitance value, less capacitance value. So from their numbering, you have to number code. From the number code, you have to decode that particular capacitance value of the capacitor. So from there, you can observe that if it is written 104 or 103 or 105, depending on that, you can have that particular capacitance value. So after that, you will have another capacitor. This is also polyester coated capacitor. So I think the numbers, if it is visible to you, numbers are visible to you. I don't think so. Okay, I can read out it for you. That numbers are written 684 and 250 volt, 684 and 250 volt. So means we can use it for higher voltage application, and from 684 we can find out the capacitance value this 6 and 8 value will directly contribute to the digit, first and second digit, and 4 will be the multiplier in picofarad. So total it will be 6, 8 into 10 power 4 picofarad, or other words you can say 0.68 microfarad. So from this value you can means from this number coding you can analyze that or estimate the value of capacitance value. Then also if you can observe here the another type of capacitor, those are very colorful capacitors are there. So there is no over all this capacitor. So as you can see that it is coded with color, different color. So basically the color code of the capacitor is similar to that color code of the resistor, means that color value of that particular color will be same as similar to resistor. But one thing you have to consider, in case of resistor, you have to start with that start with the color those who are closely spaced in from that side, left or right, if you consider for a resistor. So you have to start from those side from where you can see that the colors are closely spaced. But in case of a capacitor, if it is as you can see, it is a capacitor, and you have to consider the color codes from the top towards the bottom. So as similar to it is similar to the resistor, first two color will contribute to directly to the digit, and then third one will be the multiplier, fourth one is the tolerance, and fifth one is the voltage at which it can be operated. So there is a particular I think the voltage color is new to us. Otherwise, it is similar to the resistor. So apart from the voltage one, it will be same. So let's consider for this capacitance. Let's consider for this capacitance. I think the color, if it is visible to you, you can observe. I can tell green. Then next one is blue. Then the third one is orange, and then fourth one is and so as you can recall the color number, green is 5, then blue, blue, one second, it is blue or something else. Okay, it is blue or brown. So it is blue or brown. Blue. I think it is blue. Okay, let's consider. It is blue. So blue 6. Then orange is 3. Then we will have white, which is again for tolerance, means plus minus 10%. Then red is for voltage. And for this type of capacitance, if it is red, then it will be we can operate it in up to 250 volt. So if we calculate it, the capacitance value, so it will be 5 will directly contribute to digit 6 will also directly contribute to the digit. Then it will be 10 power 3 picofarad and plus with plus minus tolerance 10% tolerance. So basically it will be 0.056 microfarad. So in this way you can calculate that capacitance value from its color code. So the capacitance is we have to use in different experiments like LCR experiment or also other experiments we have to use. Next one is the inductor. Inductor, as you can see it from here, one small inductor is placed here. So the value of the inductor depends on the number of coil or number of turns. I think all of you are familiar with that one. So and we can also as it is we made this, so we cannot precisely tell the value of this inductance, but we have to measure in order to calculate that. We have to measure that inductance value from the multimeter. So in case of inductor, and also we are having here transformer, that is also winding of coils, and as you can see, this is a center tap transformer. Center tap transformer, we use it in our coming labs in case of full bridge rectifier. So as you can see that this is the input terminal with two connections, and this is the output terminals, and this one is the center ground, and this is for 9 volt step down transformer. 9, if you can observe it from here, 909 is written, so this will be 909 in this form, and the current will be around 500 milliampere. So this is the transformer. So, and also we forgot to tell you about the variable resistance. Variable resistance or potentiometer pot we are having also, that will be very useful for our experiment. So in case of variable resistor or pot, the direct value is written. Maximum value will be 5 kilo ohm. I think it is visible to you. So the maximum value you can obtain, or maximum resistance it can provide up to 5 kilo. So and then how to use it as a variable resistor. So if you can see, there is three terminal. Three terminal means if you connect to this N terminal, then that will be with a fixed value of 5 kilo ohm. But if you connect with any of these two, let's say if you connect these two terminal, first one, this rightmost one and center one, and if you rotate this knob accordingly, the resistance value will change. Okay, we'll demonstrate it when we'll come to the multimeter section. Then we can show you that what is the value and how it is changing depending on the knob. So and also these are smaller potentiometer. Those you can directly use it in breadboard. Okay, so these are little bit about that passive components. Those we are going to use in our coming labs. Then come to other components. First one is the diode. So as you can see here, we are having three types of diodes. These are one kind. I mean, visually you can segregate these three types. Basically, these are PN junction diode, and the number is, I think, IN40007. So this is basically a silicon diode with a cutoff of 0.7 volt. I mean, cutoff or built-in potential, whatever you can say. With that is a regular silicon diode. So in this case, if you can observe it, you are familiar with these things. I think you have come through this. So the white coated side is the N side, and this is the P side. So in this way, you have to connect P terminal and N terminal. So this is normal PN junction diode. And also these are also, I think these are LEDs, or basically light emitting diodes. So these are also kind of diodes. And if you observe here also, P and N are is given. Depending on that length of that electrode, we can uh, distinguish between two electrode, P and N. And here if you can observe, these are Zener diode, another special purpose diode. Those we are going to use for different experiments also. Specifically Zener diode experiment is also there. So if you can observe, in order to distinguish two electrode terminals, there is also one black coating is there. So that is N terminal. So P terminal and N terminal, in this way you can connect it. So these are basically different types of diode we have in lab. Apart from that, there are several types of diodes available in the market. And then come to the three electrode devices. These are the three electrode devices: transistors. Transistors, as all of you are familiar with these transistors. So then, and the transistors are having big electrodes, one with base and emitter and collector. Then the foremost question will arise: which one is which electrode? Which one is base? Which one is emitter? And which one is collector? So first thing that there are different types of transistors are there. But apart from that, if this type of transistors, if you are facing, then I don't think the writings are available. Is it visible? No, it is not visible to you. Okay, there is one flat surface and curved surface is there. Over the flat surface, numberings are there, number codings are there. From there, you have to decode what type of transformer it is. Let's say for this one, I am reading out for you. This is a BC547B. So basically, this is a NPN transistor, BC547B, and keeping the flat surface towards you, this terminal will be if, 1, 2, 3. Number one terminal, number two, and number three. So keeping the face towards you, this will be number 1, 2, 3. And depending on 1, 2, 3, it will be emitter, base, and collector. Number 1 will be emitter, number 2 will be base, and number 3 will be collector. For specifically this particular number, so you have to be careful when you are going to choose the transistor for your experiment, especially what kind of it is, NPN or PNP. And depending on that number, you have to remember that which one is emitter, which one is base, and which one is collector. And also we are having another another number transistor, another transistors. I am reading out the number for you. That is 2N3904. That is also NPN transistor. That is, but in this case, it is different. Number 3, okay. Number 3 will be the starting one. This one will be the number 3, 2, 1. Means in this case, numbering will be in this way, 1, 2, 3. And for that one, it was numbering 1, 2, 3 in this way. So the one terminal is emitter base collector. In this case, it was emitter base collector. So you have to be careful with the numbers. So we are also having different transistors. I think this one is the 558 transistor. So this is basically PNP transistor. And in this case, the numbering is same as the 548, or you can say 2N3904. So this is a little bit about the transistor, those who we have in our lab. This is all about the transistors. Next, coming to the measuring device, or you can say the first thing I would like to tell you that about that breadboard, where we actually will construct the circuit to the, So in case of breadboard, as you can see it, this is, I think you all of you are few of you are familiar with this one. All these are connected in different patterns. So if you can observe in these two lines and these two connections, there is two continuous lines and also there is two continuous connections. And these are vertical one. These are horizontal one. These are horizontal and these are verticals one. So in between these verticals are connected. Verticals, all these connections are same. Means all these ports, if you connect, let's say where 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 देखेंगे pause करेंगे. Okay, so we can check the connectivity of this connections of this breadboard line through this multimeter. So how we can measure this? So in order to operate this multimeter, as you can see, this is the multimeter we have in our lab. So how to connect, operate this multimeter, I will tell you. So if you can see, there are 4 ports are there. One is ground one. So we have to connect the black one to the ground one. And this one is the for voltage and farad and ohm also. And see, if we want to measure the voltage, means voltage and ohm means resistor and capacitance value, we have to connect in this port. And also if we want to check the connectivity or if we want to measure the diode, then you can observe that there is diode symbol is there. We have to connect it over here. If we change it over here, you can observe the white, something is written in white and yellow. So depending on this one, if you pose it, then the yellow option will be affected. Means let's say this one is the V in AC form, so AC voltage. As you can also observe, it is written VAC. So and this is the DC voltage. This is for resistance, and this is for the diode one. This is farad, means capacitor. Then this one milliampere, I cannot turn it on because in order to measure the milliampere or means current, I'm sorry, in order to measure the current, we have to turn it on to the milliampere one, and then this one will be open, then we can connect it. And if we go to ampere, then also it will not open. First we have to remove it, then we have to connect, turn it towards the ampere one, then it will open up to 10 ampere. So we have to be careful about the total current we are going to measure through it. So depending on the range, we have to connect it accordingly. So let's say in this case, if we want to check the connectivity, then we have to put it into that in this voltage and ohm and diode one. So if you can see, so I have connected over here, and if I connect these two into, yes. So if I connect these two terminal, you are getting a sound that it will signify that these two are same connections, or means these are, there is no resistance between these two paths. So now we are going to check the connectivity of the breadboard terminals, how they are connected. Let's say I am connected over here Then another one, we are going to connect it here in the same vertical line. So how we are going to take it? If we are going to connect it, if we are getting the sound, then they are connected, means there is no resistance. They are connected in through a same uh, connector. Now, if I just put it into the next one, then we are not getting the sound, which signify that they are not connected, means they are disconnected. So as we have already told you that these are vertically connected, and in this case these are horizontally connected. So let's check. So I have considered over here, and sorry, yeah, these two are connected. But if you just put it into the next horizontal line, then there will be no sound. Means these two horizontal lines are separately connected, and in this case, in between there is a gap. So means from here to here it is connected, and if you just connect it through a jumper, then all these terminals are going to connect in same line. So we are going to connect it in the middle. Then I think we will have the connectivity. Yes. So in between, in the middle line, they are disconnected. We have to connect it over there. Then we can have a total horizontal line. Those are connected. So this is the basic functionality of a breadboard. So through which we can build our circuit according to our connections. So that is why we have to consider that connections accordingly in order to perform the experiment. And next thing I would like to tell you about the power supply. So in our lab, we are having two type of power supply. So this one is the digital power supply, as you can see. So from here, you can set the voltage, and if you set this, there are two different. This one is one set of connection, this one another set of connection. And in this case, you are having that is common. So that one we are going to use it in different next experiment. Then we will tell you what is the functionality of it. For now, you can just consider these are, in this case if we are going to use it. Let's say it is written A port. So if we switch it for A, and then if we tune it, the coarse value and fine value, it will be visible over here, and also we can measure it through the multimeter too. And if we connect from here, then we can have max to max 30 volt and 2 ampere current. And if we want to tune it more precisely or more finely, then we have to tune the fine. Then now if we connect to the another terminal, E and C are there. So if we connect to the, let's say, C, so in case of C, this is the C terminal. So there is, so it is showing that 4.8 volt. If you change the coarse and fine of A terminal, it will not going to change. So in order to change it, you have to set the value from the knobs corresponding to the C terminals. Then also it is same for terminal B. So in this case, this is positive one, this is negative one, and this is the ground one. So in this, what does it mean? Positive, negative, and ground. This is a DC power supply. So in case of the experiment of op-amp that we are going to perform in another lab. So we need plus minus 15 volt, plus 15 volt, minus 15 volt, and also a zero set reference voltage. So then how you can develop, or how we can consider a minus 15 volt or with respect, and also one zero terminal and one 15 terminal. So in that case we have to use the plus one as a plus terminal, let's say, and now for this reading it is showing the 12 volt, so it will be plus 12 volt, and this will be minus 12 volt, and this will be the ground. You can check it so you can verify it from both the screen as well as the multimeter. So as I told you, the ground terminal, so or common terminal, I will connect it to the common, and if I connect it to the positive terminal, you can see that it is showing plus 12.61 volt, and in the screen also it is showing 12.5 volt. Now if I connect it to this terminal, then you can see that it is showing uh, 1 second. So it is showing around minus 22.9 volt. It is supposed to show minus 12 volt. Then let's check what is the voltage between these two. Okay. So total voltage it is showing with respect to the these two terminal is 35 volt, and with respect to the common it is plus 12 volt. That is why with respect to the common, the negative one is showing minus 23 volt. So this is the use of this minus or common source for in case of a power supply. So this is specifically DC source or DC power supply. Now, if we want to use a AC power supply with different wave pattern, then we need a function generator. So this is, we are having a function generator. You can see it, the function generator. So what is the basic functionality of it? We can have a sine wave or cosine wave, different AC signals with variable frequency as well as variable amplitude from here. So, and that we are going to measure it with the help of oscilloscope. So we are having oscilloscope in order to measure it. That you can observe the oscilloscope over here. Now I will connect the source directly to the oscilloscope. Then with the oscilloscope, you can observe the oscillation of this wave. Directly, how we are going to this generator, that we are going to observe. So oscilloscope is also another useful device, which is we are going to use it in case of, in order to show the waveform and also measure the wave. If we apply the autosync function in the digital storage oscilloscope, it will directly set to the function. So as you can see, it is showing the sine wave, and you can also zoom it, that you can have the particular peak to peak voltage and period of the sine wave. and also corresponding frequency and RMS value. All these we can measure. So and the channel one is given, the total voltage is also given. Now, if we observe it over here in case of frequency, I mean function generator. So here we have considered sine wave with a frequency of 1.1 kilohertz or 1100 hertz. We can tune the value of frequency, and as we increase the frequency, you can observe over here. You can observe from here as we increase the frequency. So the waves are also getting shrink. So from there also you can measure the frequency. So directly from a function generator, in right now we are generating a sine wave with the amplitude of 100 millivolt and the frequency of 19 hertz. So you can change the amplitude, frequency of the wave, and also type of the wave from here. So as you can observe, here is one set parameters option is there that we are going to use in order to modify the particular function. And if we change the function, we can change the function by, then we can have different function. We can have different function. So right now we have considered a triangular function. You can observe it through the oscilloscope, and it is a square wave now we have selected, and also it is ramp signal we have selected now, and also this is negative ramp, this is pulse, and this is DC voltage. So and this is sine wave. So as you can see, there are plenty of option we can play with this one. In order to explain, in order to perform any kind of experiment, we need these two components. First one is that function generator that will generate AC signal with different wave pattern, different frequency, and different amplitude. We can increase the amplitude or increase the frequency by this one. This 10 multipliers, that is plus 10 multiplier, and so if I multiply it, then frequency will increase by 10 times, and this is again 100 times, then divide by 10 times and divide by 10 times. So this is a frequency multiplication that we can have, and also we can set the attenuation from here. If we want to set attenuate our attenuate our signal, that we can attenuate from here. And amplitude also we can, if we change the amplitude, then you can observe it from the oscilloscope. The amplitude is changing. So in case of amplitude also you can have the 10 multiplier and 10 divider. So you can set the frequency as well as the amplitude of the signal with the help of function generator, and with the help of digital storage oscilloscope or DSO, you can see that particular wave function with the help of whatever it was generated by the function generator. So I think this is all about the basic introduction of the components that we have in our lab and that we are going to use for our coming experiments. Now, one thing I would like to share you, that how we can perform all these experiments on your own through this website. So the website is vlabs.iitkgp.ac.in/be/. So that is so this is VLab, basically virtual laboratory, and this is very useful you can have several experiments, not only for electronics department, for all other departments also. We have all these experiments over here you can perform, and there are so many labs also. They are under maintenance, so you can have all the list of the experiment going to this particular website, VLabs. I'm going to share my screen. Okay. If you type VLabs, then it is a very good initiative by Government of India. You can go through as per your concern, according to your time and according to your device or whatever it is. Whenever it is convenient, you can go to the website and use it. For it, you don't have to install any kind of software. You do not need anything else. You just need a device through which you are connecting to this lab. That only you can access it through the mobile also. If I can, you can use it through the mobile device also. I'll say show you how you can connect through mobile. Right now, if you I am going to share you how you can connect it to the laptop through the laptop. So let's say in this website, under electronics and communication branch, this is a broad area. Under this one, there will be several labs. So these are different labs, and developed corresponding institutes. Name of the institutes are given. So most of them are developed by all the IITs and reputed universities. So we are basically interested in this lab, basic electronics lab. So for that, you have to go to that website, vlabs.iitkgp.ac.in/BE, B for basic, E for electronics, basic electronics lab. So from here, you can observe that there are a list of experiments, and those are same, almost similar to we are going to perform in our lab. So from here, you can observe that the first experiment is the familiarization with the resistor. So here you can go click it, and then you can have all the functionality of this lab, the theory behind it, and also the quiz questions, and also reference. In this reference, there will be specific NPTEL lectures. You can go through the link, and you can have all the data, corresponding data for it, from it. Those are going to use it. So you can use it from here also, means the basic theory of it. And one more important thing, the evaluation part of your lab will be completely based on quiz. So there is this VLab portion that I am showing you right now. That is not anyhow it will affect to your grades. So it is nothing to do with your grades. If you are only interested, then you can perform the lab over here, and also you can explore several things. And if you have any query, you can come to us, and all the TAs are here to help you. But don't think we are means you will be evaluated through this, I mean via this lab or something. It is not like that. It will be completely only for your knowledge purpose. If you want to, let's say if you want to simulate the Ohm's law, I'm going to show you how to simulate this. So there is no relation between your grading and these things. If you are interested, you can explore it. And if you have also any query, then also you can ask to us how to do this and how to explore with this one. Let's say we are going to operate the Ohm's law. So let's say let's go to the simulation one. So here the beautiful thing is that you can directly verify, click it over here, you can directly verify it. Then you can draw the circuit on your own. How to draw it? For Ohm's law, the circuit is very simple, but for other experiment also, you can draw it on your own. Let's do it one by one. Let's say Ohm's law, we are going to verify it. if you just click it, then this is the most, I think all of you go through this Ohm's law experiment in your 12th standard. So let's say you have set a particular resistance 79 or 85, let's say 10 kilo ohms. Oh, okay, let me set it. You just yes, it is 10. If you just change the slider, then resistor value will change. Now if we by keeping a constant resistor, if you just consider the voltage, if you vary the voltage, let's say if you add the voltage to your voltage table, then you can observe that for the serial number 1, the voltage is 3 volt and current is 0.3 milliampere. So it is recorded. Now let's say if you want to change the voltage from 3 to another value, then add it to the table. Let's say it is 5 volt, and corresponding current is also getting noted down in the table. Let's say for 9 volt, and if you just change the slider to its higher value, 16 volt, and let's add another value, 19 volt. Okay. So these are the value that you can add it, and the most beautiful thing is that you can plot it. You can plot it. If you plot, then you can have the nature of the particular graph, how it is showing. So in order to perform the experiment in real life, you have to set this experiment. Then you have to vary the voltage through the source from the DC supply. Then you have to measure the current. Then you have to collect all the data in your record book, then you have to plot it. But in this case, you don't have to do anything. You just have to, if you have any query, then let's say for this one, you note down all this data on your own. Now, I mean, to you, then just change the resistance value, then check what is the effect. You can check it. You can so from there you can clear all the value. Then let's say you have changed the resistance to 60, then also you can change the voltage just by varying the slider, and you can plot it again you can plot it. So it will be very helpful to you if you just collect different data for different resistance value and plot them together. So that is not possible over here. That you have to do on your own. So if you can do it, then I think you will come up with some idea that what is the effect of for same voltage value, why we are having different current for different resistance value. Okay, so this is the verification. This was the verification part. And also, let's say we want to draw the circuit on our own. Then you have to click the Ohm's law draw circuit. And okay, so let's do it. Okay, so initially you observe that it was connected and only the meters are there, and you have to change the slider. Now nothing is connected. How we are going to perform the experiment? So this is very similar to the real life experiment. Means you will have in real life, you will have all these components in discrete form, and you have to put them together in breadboard, and you have to connect it. So anyhow, you can also do it over here. Let's say this is our voltage source, and from voltage source we are going to connect it to resistance. And from the ground terminal we are going to give it into ground, then through the resistor, then this will be the the emitter will be in series, then it will come back to this point, then let's say the voltmeter, that will be in series, parallel to the resistor. Now you can check whether your connection is wrong or right. If you check the connection, it is written right connection, set resistance value and input DC voltage. So if you do something wrong, let's say, that is the beauty of it, that is not let's say I'm going to delete all the connections and going to make a wrong connections. So let's say what will be happen. So in real life, if you do wrong connections, that device may just goes wrong, or that may not work properly. But in this case, let's say, suppose I am connecting this ammeter parallel to the resistance, and this voltmeter also to parallel. So as I mean that is wrong connection. So you can see it that I did it intentionally wrong, and I want to check whether my connection is wrong or right. So it is written. So it is wrong connection. So if you want to do a right connection and unintentionally you have done some mistake, it will show you that no, it is wrong connection. So that is, I think, a most beautiful thing, that you can really perform all the experiments that we are going to demonstrate over here. You can do it on your own, and then I think it can give you somehow a feeling that you are doing it on your own in real life experiments. So this is the circuit component, circuit drawing component one. And also there are several things like Ohm's law for resistance in series. Ohm's law for resistance in series draw circuit means there are two things. Always you can verify it, only just varying the voltage means taking the readings, and also you can draw the circuit. Then also Ohm's law for resistance in parallels. I think all of you can explore these things and come up with your ideas, that something you have learned. Uh, Apart from all this theoretical learning, I think this will be a very good platform. You can explore it for, and also verifying non-ohmic diode. Also, all these things are there. And also one more beautiful thing is that uh, I don't think it will be beautiful for you. There are assignments. Assignments are also there. If you are interested, you can go through this assignment, and also you can have this quiz. You can do the quiz on your own, and from that you can explore it. So there are multiple choice type quiz are also there. All these are depending on this lab. So basically it will going to help you to your knowledge, and also in this lab you will be evaluated through quiz only. Maybe that will help you. So in this case, so you can explore it through this website. It is also, you can do it from mobile also, or any kind of device, mobile, laptop, iPad, pad, or anything that through which you have a browser, HTML5 coding supported browser. And I think all of the latest browser will support this coding. So you can explore it on your own. So I think this is all about from the first lab, and see you in the next lab with your all the queries. And I hope you will perform all this experiment in this virtual platform, and you can have with your query, and you can share it with through that I think contact numbers will be given. You can directly contact to us or email to us, whatever will be suitable for you. You can ask your query. Thank you.